This is the question paper of 2016 Differential Equations for Generic 3rd. It has 6 questions and each question has 3 parts. We have to attempt any 2 parts from each 6 questions, so we have total 12 questions to attempt. Distribution of marks are given in the question paper. We have to solve all 12 questions in 3 hours and the question paper is of 75 marks. Now let's start to solve this question paper. Question number first A. इसमें पूछा है find an integrating factor and solve the differential equation. इसका solution हम लिखेंगे given differential equation is number 1. सबसे पहले हमें इसमें integrating factor find out करना है. So for integrating factor let m equals to e to the power x plus y minus y. This is m and n equals to this value x plus y plus 1. ये हमने लिखा है m dx plus n dy equals to 0 से कंपेयर करके. So हमारे पास एक रूल है इंटीग्रेटिंग फैक्टर निकालने के लिए, वो हम अप्लाई कर रहे हैं. तो डेल m ओवर डेल y इक्वल्स टू सीधे पार्शियल डिफरेंशिएट किया है m को विद रिस्पेक्ट टू y e टू द पावर x प्लस y माइनस 1. सिमिलरली डेल n ओवर डेल x इक्वल्स टू प्रोडक्ट रूल लगेगा यहाँ पे. सो मैं डायरेक्ट लिख रहा हूँ x प्लस y x e to the power x plus y, this is plus 0. Now del m over del y minus del n over del x equals to, rather डायरेक्ट हम निकाल लेते हैं अपॉन n करके. सो ये क्या हो गया e to the power x plus y minus 1 minus e to the power x plus y माइनस एक्स ई टू द पावर एक्स प्लस वाई अपॉन एन की वैल्यू एक्स ई टू द पावर एक्स प्लस वाई प्लस 1 इट इक्वल टू दिस इज कैंसिल आउट. सो माइनस 1 is common, then plus x e to the power x plus y, then x e to the power x plus y plus 1 equals to minus 1. So integrating factor equals to e to the power this function into dx by rule. So e to the power minus x integrating factor. तो पहला इसमें पार्ट था, पहले इस क्वेश्चन का पार्ट था फाइंड इंटीग्रेटिंग फैक्टर. अब हमें इसका यूज करके इस डिफरेंशियल इक्वेशन को सॉल्व करना है. तो मल्टीप्लाइंग इक्वेशन 1 बाय इंटीग्रेटिंग फैक्टर. सो e टू द पावर माइनस एक्स से मल्टीप्लाई करना है हमें. ये हो गया e टू द पावर x प्लस वाई माइनस वाई डी एक्स प्लस डी वाई इक्वल्स टू 0. सो इट बिकम एंड प्लस इसको इक्वेशन नंबर डाल देते हैं 2. नाउ इक्वेशन 2 बिकम exact differential equation. For this exactness we can check del m over del y equals to del n over del x. हमने इसको m ले लिया, इसको n. So del m over del y equals to del n over del x equals to both are same. So this is exact. वैसे भी जब इंटीग्रेटिंग फैक्टर हम निकालते हैं वो इस डिफरेंशियल इक्वेशन को एग्जैक्ट बनाने के लिए ही निकालते हैं, तो उससे मल्टीप्लाई करके वो एग्जैक्ट हो जाता है. ये दिखाना नेसेसरी नहीं है, फिर भी मैंने आपको बता दिया. integrating equation 2. So this, बस यहाँ पे ध्यान रखना है, इंटीग्रेटिंग के लिए एक रूल है, जब आपका डिफरेंशियल इक्वेशन एग्जैक्ट हो तो यहाँ पे क्या होता है, कीपिंग y इज कांस्टेंट. y जो होगा वो एज ए कांस्टेंट की तरफ बिहेव करेगा. सेकंड में टर्म नॉट कंटेनिंग x. अब सेकंड में लेकिन क्या है, यहाँ पे भी टर्म x आ रहा है, यहाँ पे भी x आ रहा है. सो 0 इक्वल्स टू सम कांस्टेंट c. दिस इज टर्म नॉट कंटेनिंग x. We have e to the power y. This is x minus y e to the power minus x. This is 1 equals to c. So x e to the power y plus y e to the power minus x. This is required solution. So यहाँ पे हमारा जो क्वेश्चन होगा completely solve हो गया है. आप इसको वेरीफाई भी कर सकते हो, आपका सोल्यूशन सही है या नहीं है चेक करने के लिए आपको एक बार इसको डिफरेंशिएट करना पड़ेगा. जो डिफरेंशियल इक्वेशन गिवन है वो आ जाएगी. तो जरूरी नहीं है यहाँ पे, क्योंकि उसने पूछा नहीं है वेरीफाई के लिए. क्वेश्चन नंबर 1 पार्ट बी. सॉल्व द इक्वेशन y डैश प्लस x प्लस 1 y equals to e to the power x square y cube and y 0 equals to 0.5. This is initial value problem. तो इसका सॉल्यूशन हमें लिखना है. तो सॉल्यूशन इसको नंबर दे देते 1 इस इक्वेशन को. This type of equation is called Bernoulli equation. So we reduce this differential equation to first order linear differential equation. तो इसके लिए क्या करते हैं हम, y क्यूब जो है यहाँ से y क्यूब को हटाना होता है. y क्यूब से हमें पूरे इक्वेशन को डिवाइड करना है. तो 1/y क्यूब y डैश प्लस x प्लस 1/y स्क्वायर हो जाएगा e to the power x स्क्वायर. अब put 1/y square equals to z. Differentiate with respect to x. So we get minus 2 cube dy over dx equals to dz over dx. 1/y cube y dash equals to, we can write minus 1/2 dz over dx. So this is equation say 2. This is 3, this is 4. Using value of 3 and 4 in equation 2. So we get minus 1/2 dz over dx. इसकी वैल्यू पुट कर दी, प्लस x प्लस 1/y स्क्वायर हमने z लिया है, तो z e टू द पावर x स्क्वायर. तो dz ओवर dx minus 2x plus 1 z equals to minus 2 e to the power x square. This is equation 5. अब ये फर्स्ट ऑर्डर लीनियर डिफरेंशियल इक्वेशन में कन्वर्ट हो गया. तो इसका सॉल्यूशन हमें पता है. सबसे पहले इसमें क्या करते हैं, इंटीग्रेटिंग फैक्टर निकालते हैं. तो इंटीग्रेटिंग फैक्टर e टू द पावर दिस वैल्यू minus 2x plus 1 dx is equal to e to the power minus x square minus 2x. This is integrating factor. So we know that general solution of first order linear differential equation, that is equation 5. यहाँ पे dependent variable है z, dependent variable into integrating factor equals to integration right hand side क्या है यहाँ पे 2 into minus 2 into e raised to x square, and फिर again integrating factor dx plus constant. So z integrating factor is e to the power minus x square minus 2x minus 2 x square, integrating factor c. तो z इक्वल्स टू क्या हो जाएगा, e टू द पावर x स्क्वायर प्लस c e टू द पावर x स्क्वायर प्लस 2x. So this is the general solution where z equals to 1 upon y square. Therefore 1 upon y square equals to e to the power x square plus c e to the power plus 2x. Thus 1 upon y square equals to e to the power x plus c e to the power x square plus 2x. Now initial condition is given, which is y0 equals to 0.5. Imposing this condition in this solution, 1 upon 0.5 square equals to e to the power 0 plus c to the power 0, that is 1 plus c, that is 4 equals to 1 plus c. Therefore c equals to 3. Thus 1 upon y square equals to e to the power x square plus 3 e to the power x square plus 2x. Therefore finally y square equals to 1 upon plus 3 e to the power x square plus 2x. This is the required solution of given differential equation. Question first, part C. Find the orthogonal trajectory of the family of parabola. This is given family of equation where C is parameter, that is, this is the one parameter family of curve. Now we need to find orthogonal trajectory. To find orthogonal trajectory of equation 1, first we eliminate arbitrary constant or parameter c from the equation 1. We can write equation 1. Now differentiating with respect to x, we get y dash e to the power 3x, then plus y into 3 e to the power 3x equals to 0. So y dash plus y into 3 e to the power 3x equals to 0. Since e to the power 3x cannot be 0, y dash plus 3 y equals to 0. This is equation 2. So we eliminate c from this equation and get this differential equation. Now we know that by condition of orthogonality at point, that is, for finding orthogonal trajectory, we just replace y dash by minus 1 upon y dash. From 2, minus 1 upon y dash plus 3y equals to 0. So 1 upon y dash is equal to 3y, that is 3y, y dash is equal to 1. So now variable separable, 3y dy equals to dx. We can write this y dy equals to 1/3 dx. On integrating both sides, y square by 2 equals to 1/3x plus c by 2. C is here, so we take c1 by 2, so y square equals to 2/3x plus c1. This is the required orthogonal trajectory. For better understanding about orthogonal trajectory, you can watch my video which was already uploaded in the mathematical science. Question number 2, part A. So that e raised to 3x and x e raised to 3x form a basis of the following differential equation: y double dash minus 6y plus 9y equals to 0, and find also the solution that satisfy the conditions y0 equals to minus 1.4 comma y dash 0 equals to 4.6. e to the power 3x and x e to the power 3x form a basis. We are sufficient to show this function are linearly independent. So let y1 e to the power 3x and y2 equals to e to the power x e to the power 3x, and c1 y1 plus c2 y2 equals to 0. c1 e to the power 3x plus c2 x e to the power 3x equals to 0, that is c1 plus x c2 3x equals to 0. Since e to the power 3x cannot be 0, so c1 plus x c2 equals to 0. If x equals to 1, c1 equals to minus c2, and if x equals to minus 1, then c1 equals to c2. Yeah, c1 plus c2 equals to 0. Yeah, c1 minus c2 equals to 0. On solving these two equations, we get c1 equals to 0 and equals to c2. Thus, y1 and y2 are linearly independent. Thus, e to the power 3x and x e to the power 3x form a basis of this equation. Now second part है इनिशियल कंडीशन गिवन है और इस डिफरेंशियल इक्वेशन का हमें सॉल्यूशन फाइंड आउट करना है. सो दीज आर बेसिस, दैट इज दिस फंक्शन आर सॉल्यूशन ऑफ दिस इक्वेशन. सो बाय सुपरपोजिशन प्रिंसिपल y equals to c1 y1 plus c2 y2 is also solution of 1. Therefore y equals to c1 e to the power 3x and c2 x e to the power 3x is also solution. So we have initial condition y0 equals to minus 1.4 and y dash 0 equals to 4.6. So imposing this condition in this equation, so we get minus 1.4 equals to c1 e to the power 0, that is 1, c2 into 0. It implies c1 equals to minus 1.4. Now we have this condition, so we first differentiate this solution. Y dash equals to 3c1 e to the power 3x plus c2 by product rule 3x plus x 3 e to the power 3x. Now imposing this condition, 4.6 equals to 3c1, and this is e to the power 0, that is 1 plus c2, this is 1 plus this is 0. So 4.6 is equal to 3 into, this is value of C1 is minus 1.4 plus C2. So C2 equals to 8.8. So using, this is equation 2. So using value of putting value of C1 and C2 in equation 2, we get y is equal to, this is C1 minus 1.4 e to the power 3x and plus 8.8 x e to the 3x. This is the required solution or particular solution. Differential equation 1. Question number 2, part B. We have to solve initial value problem. X squared y double dash plus 3xy dash plus y equals to 0, and initial condition is y1 equals to 4 and y dash 1 equals to minus 2. We can write this differential equation as x square d2 plus 3x d plus identity function I and y equals to 0. This is equation 1. Because this is Cauchy-Euler equation, we have method for solving this type of equation. First we put x is equal to e to the power z. It implies z equals to log x. Here x is the independent variable. Now we change this independent variable by z by putting this condition x equals to e to the power z. Then we know x square d square equals to theta minus 1 x d equals to theta, where theta is d over dz. For detail you can watch our video in mathematical science. Now using this value in equation 1, we get theta minus 1 plus 3 theta plus, this is identity operator, then this is theta square plus 2 theta plus I equals to y equals to 0. This is equation 2. Now this is the differential equation with constant coefficient. We have general solution. First, for this auxiliary equation of 2. So lambda square plus 2 lambda plus 1 equals to 0. It implies lambda equals to minus 1 because this is lambda plus 1 ka whole square. Double real root. For this we have solution y equals to c1 plus c2. Here z is the independent variable for this function, so z and e to the power minus z, but e to the power z equals to x, so we can write c2 log x, and this is x to the power minus 1 or upon x. Now imposing this initial value, so since y1 equals to 4, we get 4 equals to c1 plus c2 log 1, that is 0 upon 1. It implies c1 equals to 4. Similarly, since y dash 1 equals to minus 2, but we have y, differentiate this equation with respect to x. Now imposing this condition, this is minus 2, then minus c1 upon 1 plus c2, there is 1 and this is 0. So c2 equals to minus 2 and c1 is 4, that is plus 4. It implies c2 equals to 2. Therefore, putting these c1 and c2 in this equation, this is equation 3, we get y equals to, what is c1? C1 is 4 plus 2 log x upon x. This is the required solution, yeah, particular solution. Question 2, part C. Since the given series is, say, s equals to n equals to 2 to infinity to the power m, x minus 1 to the power 2m upon 4 to the power m. Let m equals to 2m equals to n, then we can write, so 2m equals to 4, that is n equals to 4 to infinity minus 1 to the power n by 2, x minus 1 to the power n upon 4 to the power n by 2. Now this is the standard form of the power series. Now comparing this power series by, let an equals to minus 1 to the power n by 2 and 4 to the power n by 2. We have formula for finding radius of convergence. 1 upon r we know that 1 upon r equals to limit n tending to infinity, this is mod an to the power 1 upon n. This is limit n tending to infinity mod minus 1 n by 2 upon 4 n by 2, 1 by n power 1 by n. So limit n tending to infinity, so this is 1 and this is 4 to the power 1 by 2, that is 1 by 2 upon r. Therefore r equals to 2. This is the answer.